On Gemini 8, I'd been assigned as one of the capsule communicators. This was the first time I'd ever done that job, which we called Capcom. And early into the flight, I took over from Jim Lovell. It seems to me it was late at night. The mission had been a little boring almost. The spacecraft was up there somewhere over the Soviet Union. And I don't remember exactly what Jim or I said. It was sort of a quick status report, but nothing memorable. And Jim left. No sooner had Jim gotten out of the building when we had contact with the spacecraft, but immediately knew that there was a problem. The spacecraft was spinning out of control. The spin was accelerating. The crew didn't know why. They knew they had some kind of stuck thruster, but they didn't know which thruster. There was a lot of them. They were docked with the Agena rocket. It could have been a thruster stuck on the Agena, and indeed, Neil Armstrong jumped to the relatively logical conclusion that since everything had been okay up to the docking, and they had just docked, that it was probably something wrong with the Agena. So he undocked. As soon as he did, the spacecraft began to accelerate in its motion, which meant that without the Agena mass there, now the thruster must have been on the spacecraft. And they had great difficulty isolating where the problem was. They turned everything off, but they were still spinning. And so after quite a bit of confusion, justifiable confusion, both in the air and on the ground, they were able to stabilize the spacecraft by selectively turning thrusters on and off to find which one was stuck. They isolated the stuck one, brought the spacecraft back under control, but they had used a lot of their attitude control fuel. And because of this, they backed into a mission rule that said when your attitude control fuel gets such and such low, then we have to have recovery, because we can't afford to let the spacecraft go any longer. So suddenly, I was counting them down to a re-entry, out in the middle of the Pacific Ocean. No ships to speak of, no aircraft carrier standing by. So this was quite a baptism in fire to me, and fortunately, they floated around there for quite some time and were picked up by a destroyer. But this experience stuck in my mind and actually came back and related to another problem that we had on Apollo 8.
How so?
Well, on Apollo 8, we were coming back from the moon. Frank Borman had gone to get some sleep. I was flying to the degree you can fly a spacecraft falling down from the moon, flying the spacecraft. Jim Lovell was down in the navigation bay doing star sightings to test the navigation equipment. We really didn't use the navigation equipment on board for that first flight out to the moon. And Jim, in his haste, hit the wrong button on the computer, which caged the gyro, which sent the attitude reference system to 0, which lined it up with the spacecraft, where it was supposed to be lined up with, the universe. And so I suddenly saw the attitude ball in front of me starting to move. Coincidentally, one of the thrusters fired that was taking care of the attitude of the spacecraft. And I jumped to the conclusion that, oh my God, we've got a stuck thruster, just like Gemini 8. So I came in with a hand controller in the opposite way to counteract this thruster, and was trying to take the movement out. I couldn't do it, so I came in with more. Actually, what was happening was the ball was just moving inside the instrument panel on its own. The spacecraft had been, up until that moment, perfectly neutral, until I put the thrust in. And then I saw that the shafts of light from the sun hitting little dust motes in the air was moving. So that further convinced me that we had a stuck thruster, came in with more thrust. Frank Borman woke up about this time, what the hell's going on? I said, I think we got a stuck thruster. And then I realized that the light was rotating the wrong way for this thruster being stuck. And by this time, the ball had now zeroed out. And then I realized, oops, It was because of this caging of the gyro system that made it look like a stuck thruster a la Gemini 8, but really wasn't. So we quickly brought the spacecraft back under stability, but we didn't know where in the hell we were with attitude. And poor Jim Lovell, of course, was being debriefed by Frank pretty thoroughly by this time. You couldn't see very many stars because sunlight was reflecting off water and urine crystals that were microscopic but floating around the spacecraft. And so it was very difficult for us to reorient the reference system, which had to be done because we were about 24 hours out from reentry. And if you re-entered with the wrong attitude, the wrong spacecraft attitude, you could skip out or dig in, and that was both lethal results. But fortunately, Jim's sharp eyes and a little help from the ground, we managed to shoot a few stars and eventually stumble on the right combination. And the computer said, yay, verily, we know where we are now. But that stemmed from Gemini 8.
So, talking about this, though, you're talking about real test pilot attitudes when you talk about Gemini 8 and it's spinning out of control. Let's talk about the fire for a second. Where were you when you heard about the fire? And when you heard about it, did it surprise you?
I was home. I'd been in the simulator half the night, and so I had gone home. I was called by my friend Al Bean and was told that since I was the nearest to the White residence, that I should go over and tell Pat White that her husband had just burned up. I can remember driving over there perplexed of why this happened, because Apollo, in my view, had been so thoroughly thought through, much more than any airplane that I'd ever flown or tested. Yet in retrospect, it was amazing to me that they had missed a extremely, in retrospect, obvious point. That if you take oxygen at 100% and pressurize it above atmospheric pressure, in this case 5.5 pounds above atmospheric pressure, then almost anything will burn. An asbestos anti-fire blanket will burn under those kind of pressures. And there must have been 50 people or 100 who, including the crew, who knew that they were going to do this one test for the first time with 100% oxygen, pressurized above atmospheric, because this spacecraft was just sitting at the bottom of the atmosphere, and they wanted to test its leakability, not with air, but with oxygen. They'd combined two tests, one of the oxygen system and one of the pressure system, and that was the fatal flaw, and yet nobody said, whoa, wait a minute. You walk into any hospital where somebody's on 100% oxygen in a tent where the pressure is maybe 1 millimeter above atmospheric, and there's always a no smoking sign. And so one little spark set it off, and once that happened, there was no stopping it.
Did you have an attitude or a feeling about these test pilots who you said you went and told Pat White about her husband? What was your attitude about that as part of this business, test pilots?
Well, the people who were selected for the program had been culled, if you will, by their past experience, down to a group who either had some kind of emotional flaw, that didn't worry them that much, or we like to think down to rather steely-nerved types. And so, if my own, just speaking for myself, I thought and still think that Apollo and going to the moon was safer than some of the flying I'd done as an Air Force officer, as a fighter pilot, up in Iceland, flying in terrible weather with loaded airplanes, and certainly at that time, it was, in my view, safer than being a fighter pilot in Vietnam. And so this was, we had selected these careers because we had decided that for whatever benefit we saw in it, personal satisfaction, serving the country, blah, 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 that it was worth it to take these risks. I don't think anybody didn't think there was a risk. Now, I don't know that Grissom, White, and Chaffee had contemplated, burning up on the ground in sort of an ignoble way. I mean, they weren't even on a mission, and it was, sad if they were going to die, that it wasn't in a way that where they had been training. But basically, we had accepted these kinds of risks. I thought in the case of Apollo 8 that we had one chance in 3 of a successful mission, one chance of 3 of an unsuccessful mission yet surviving, and one chance in 3 of an unsuccessful mission and not surviving. And I had 5 kids. And so it played on my mind. It wasn't me losing so much, but my wife, who we couldn't get insurance. And yet I had decided and talked over with her that the benefits, personally to me, of the fulfillment of a fighter pilot, test pilot career, the ability to participate in a marvelous exploration program, and to serve my country, all boiled down to being worth it.
Great. We ran out of film. That's why it was good. It was good. We got the. Okay, 1 second. Landers, 127. Take 1.
Well, I had 5 kids, and my wife, we couldn't get insurance, and so it wasn't so much me at risk as it was the family. And yet, she and I had weighed the risks. We talked about the pluses and the minuses. We talked about the fact that this would be the culmination of my military test career, flying on Apollo. It was a wonderful exploration to be involved in. Certainly wanted to land on the moon, but going to the moon, the first humans, nonetheless, was still a wonderful experience. And not the least to be able to serve my country in a nationally important program, all balanced down to the various risks, most of them unknown, some of them reasonably predictable, were worth it.
It takes me back to competition for seats. I mean, in Alan's book, Deke made a lot of seats. How much those seats were precious. How did you feel about that? Was it a competitive nature? You guys are all competitive. That competitive nature. How did one make sure that he got a seat?
Well, we, as you can imagine, speculated a lot on what were the criteria of getting a seat on one of the Apollo flights. In retrospect, all our theories were much more complicated, overcomplicated. What it really boiled down to, if one can believe Deke's book, which was written by a third party nonetheless, but he had a chance to review most of it before he died, was that basically you just stood in line, and when your turn came up, almost independent of your qualifications, if you made it, you were qualified in his view. I didn't share that view, but nonetheless, you stood in line, and when your turn came up, you got a seat.
What was your motto?
Motto for seats?
You had an ethos about work hard and you'll get noticed.
Well, I thought that the harder one worked and the more one could stand out doing whatever task was assigned, the more one would be rewarded. That turned out to be not the case. I mean, surely it wasn't you could get a seat no matter what. Some of the people did, trip up and get sidelined to a degree. But there wasn't the kind of selection process that I'd been used to in the Air Force, where if you did a good job, generally got a good assignment, and if you didn't do a good job, no matter how much you were great around the bar, it didn't count.
During these early days, even before Apollo 8, the notion of getting geologists involved, getting scientists on these missions. I know there was some resistance in the astronaut corps. Now, as a test pilot, what was your reaction when you first heard that they were going to try to get some scientists on these flights, trying to get some geologists into these seats?
Well, just to waste a little of your film here, I wasn't a test pilot. Okay, I had been in flight tests, but I didn't go to the Edwards Test Pilot School, so I was a little bit of an oddball. I was sort of the politically correct, I guess. They're going to let a few technical people in so long as they almost look like test pilots. That put me at the back of the line to start with. I was interested personally in geology even before I came to NASA. So I participated in all the geology they had to offer and then some. This probably worked against me because that really wasn't the right stuff, you know. So I thought that, okay, we're going to the moon really as a political program to demonstrate technological preeminence to the United States and to the rest of the world that the United States is better than Russia. And the real reason is to jam that flag on the moon, and that's about it. But while we're there, oh, by the way, let's do a little lunar geology. Let's do a little exploration. And that was a major motivator for me. And yet I realized that, though I thought I was a pretty bright guy and picked up, you know, at least the superficialities of geology pretty quickly, that I really wasn't a geologist. And it seemed to me unfortunate that here we were going to have quite a few lunar landings, and there was no geologist on the manifest. When I went to Washington on the Aeronautics and Space Council to help set out the future part of Apollo, one of the authorities that I interacted with was a fellow by the name of Bill Pecora, who ran the United States Geological Survey. And one day on an airplane flight back from someplace that he and I had both given a talk to some convention, we brought up the fact that there were no real geologists on Apollo. And I told Bill, I said, look, NASA needs you for another program called Landsat. You have some political clout with NASA. Why don't you make a trade with them? Why don't you tell them you'll support them in Landsat if they'll put a real geologist on the moon? Well, I don't really know exactly what happened, but about 3 months later, NASA switched crew members on the last flight and put Jack Schmitt on the crew.
Interesting.
And he's a real geologist.
Yeah. Interesting. Now,
Jack, by the way, hates that story. He thinks he got there on his own.
yeah, right. Well, what about Apollo 8? You were working with Borman and Lovell. I know Lovell came on a little later. When did the mission change, and how were you notified, and how did you feel about it?
My recollection of how and when the Apollo 8 mission changed was I was out at Downey with Frank testing the Apollo 8 command module. And I had been assigned to the lunar module. I was the lunar module pilot, and I thought, well, I'm not going to go to the moon on the first flight of the lunar module. I'm going to test it in Earth orbit. But that, plus the fact that I had been heavily involved in the lunar landing training vehicle to learn how to land on the moon. Neil Armstrong and I had come from Gemini before the fire as the backup crew on Gemini 11. He and I were the first two to train in the lunar landing training vehicle. So I thought, well, this looks good, you know. And so I'm getting a lunar module on Apollo 8, and that all adds up. So maybe on about Apollo 14, I'll cycle into a lunar landing, which is really what I wanted. But the lunar modules, all of them, were falling behind schedule, and I knew that there had to be some give somewhere, but I just didn't, that was above my pay grade as to how they would handle that. So Frank informed me that the decision had been made to take Apollo 8's lunar module away from it. I don't even think we were called Apollo 8 at that time, something else, but we were going to lose our lunar module. I was going to become the command module specialist. I don't think Jim had just barely come onto the flight, and that we were not going to go testing a lunar module in Earth orbit. We were going to go around the moon for the first time, and the humans had ever left the influence of Earth's gravity, and we were going to do it for the first flight on the Saturn V. My initial reaction was not all the good things about that. Was, well, I'll be damned. I'm losing my lunar module. I'm being put on the command module monorail track. That doesn't bode well for a lunar landing for Bill Anders. And so that bothered me a lot. But when you get dealt lemons, you got to make lemonade out of it, and a lot of people would have killed to have my bad job. So I have rationalized that, well, I guess I would have rather walked on the moon on the third or fourth landing, but to be able to participate in humankind's, not just America's, but humankind's first flight away from the Earth on Apollo 8 was pretty special.
Great, terrific. Okay, cut.
The Lunar Landing Training Vehicle was one of the many simulators we used in order to condition the pilots to be able to land on the moon. The moon being airless, so there was no drag, no wind, and the moon having 1/6 the force of gravity. They started out in our training by teaching us how to fly helicopters, and that was useful. Now, I didn't land on the moon, so I have to project a lot of this. But one difference about a helicopter is that it has its mass, but it's a mass influenced by Earth gravity, which is 6 times that of the moon. So the degree that mass is involved, without getting into a high school physics lesson, you're going to get fooled by training in a helicopter on the Earth as opposed to a helicopter on the moon if there were, of course, an atmosphere, which there isn't. So NASA came up with this lunar landing training vehicle, which took out 5/6 of Earth's gravity and all of the atmospheric drag aspects in a computer that gimbaled a jet engine that took care of the Earth aspect of the flying and provided the same kind of rocket thruster dynamics that the lunar module would have. And it was an amazing training vehicle. In my view, there should be a special show on the lunar landing training vehicle.
Was there a lot of competition between you and Armstrong as to who can fly that thing better?
Yes, he lost, but well, Neil. In fact, the difference in technique between Neil Armstrong and I resulted in Neil almost getting killed, and I only say that because Neil's technique was that of truly of a test pilot. He wanted to have everything perfect when he started. I was quite satisfied with the more pragmatic approach, so I flew it the morning before Neil had his almost disastrous flight. The same problem was in that vehicle when I flew it that was in it with him. And so our technique was to go up to 500 feet, stabilize, and make a lunar landing trajectory.
Cut. Just ran out of film. I'll pick this up on that. Roll number 35.
So the object was to go to 500 feet, stabilize the vehicle, and make a lunar landing trajectory. Now, stabilization meant switching from full jet engine lift over to rocket engine lift, as to assisted rocket engine lift, and then going and making a landing. And the idea was to hit the ground at a particular spot within certain parameters so you wouldn't break it, not to mention breaking your own neck. This day the wind was kicking up a little bit, and so I got to altitude. I wasn't perfectly at 500 feet. I didn't have exactly the right parameters, but I was in control. And so I went ahead and made not only one landing, I made the lunar landing trajectory. We had about 2.5 minutes of fuel, so you had to do this pretty fast. And then I made several other just pop up and down touchdowns within the fuel limits. And they weren't world champion perfect trajectories, but from a training point of view, in my view, they were totally adequate and everybody was happy with it. And so I got racked up for a written, Anders made 4 or 5 landings. That was kind of good. When Neil flew it several hours later, now the wind had kicked up a lot more. And Neil, being a very precise test pilot, and that's that's his training, and he wanted to make sure that everything was just exactly right. So when he got to 500 feet, he spent a lot more time getting the parameters of start just right, the right velocities, the right position, blah, blah, blah. At the same time, this vehicle was automatically correcting for the crosswind. It was tilting over. So that it was leaning into the wind so that Neil wouldn't have this crosswind sensation in the training vehicle because he wouldn't have it on the ground. It had 2 rocket fuel tanks, 2 round tanks, one on each side of the vehicle with a cross feed between them. So while Neil was up there getting the near perfect start, fuel was draining from one tank to the other. Now that didn't make that much difference because we thought we had low-level fuel sensors in both tanks. And we did have them in there, but the uphill tank sensor, we didn't know it, but had failed. So unbeknownst to Neil and the people on the ground, the fuel level came down very low in that tank. And Neil wasn't given a warning, and he's a very bright guy, and had he been, he'd have gotten his tail on the ground real fast, and the people on the ground would have ordered him to do that. So Neil, thinking he still had enough fuel, started down his, better than I had trajectory, and he was slower, making more precise movements, and when he got down near the ground, suddenly the other light came on. The other sensor detected low level, but he thought he had a little more time, so he continued with his landing, but not at a rapid pace, which is all sensible if you assume everything's working. And just about prior to touchdown, he ran out of attitude fuel. He ran out of the fuel to control the attitude of this vehicle. So now it was like a kid's balloon at a party where they blow it up and let it go. And it just started, and Neil came up on the throttle to get away from the ground, because it's the ground that kills you, and got up to altitude, but now this thing looked like it was going to roll over on its back. And somewhere along the line, it, on its own, because he couldn't control it, it came sort of right side up and he ejected.
That's famous footage. Just cut for a second. Bill Anders, take two. Describe the command service module. What's it like?
Well, it's a very complicated device, very crammed in, and from a visibility point of view, I guess it's a lot like a submarine. Those submarines really don't have windows, but they do have a periscope. But the ability to see out of a command and service module is very limited. And in our case, particularly, our windows got fouled very early in the flight. Some of the sealant on the inner panes leaked into the airspace between the panes and put a greasy, oily smear, particularly on Frank Borman and Jim Lovell's window. Fortunately, my side window, for some reason, didn't do it as much. But we were very limited in our visibility out of the command and service module.
Describe coming down to the moon the first time. You didn't come in looking at people's image of it is, they came in, they could see the moon out in front of them. Describe the reality of it and your first impressions.
When we were going into lunar orbit, we were going backwards. We were in total darkness. We were in the shadow not only of the sun by the moon, but we were also in the shadow of Earthshine. So we were in the double umbra. It was very black. All there was we could see over our shoulder was a black hole with no stars. And we assumed that was the moon. In fact, the only time of the flight that my hair kind of crawled on the back of my neck going into this big black hole. We were counting down to turn on the service propulsion engine, which would slow our velocity down so that we could be captured by lunar gravity. If we hadn't slowed down, we'd have been slingshotted out around the moon and back to the Earth. So just as we were in the middle of this countdown, with not very many seconds to go, I noticed something caught my eye out of my window. My first reaction that it was somebody pouring oil down the window. Now, of course, there was no gravity to speak of, and so the idea of oil running down the window, I was getting a non-compute in my brain, but that's what it looked like. And then I refocused my eyes and realized it was early lunar sunrise in a sense. It was actually sunset, but to us it was sunrise because we were seeing light on the moon for the first time, very rough mountains, very low sun angle, and these were the lunar mountains coming up the window through kind of a purplish haze of some kind of material smeared on our windows. And it was really interesting to look down there, and it frankly took my attention away from the countdown. And Jim Lovell, both he and I remarked about it, but soon our spacecraft Führer, Frank Borman, got us back on track, and we went through the countdown.
What was the highlight of that whole time? I mean, were there any
in lunar orbit, or just to seeing the first?
Just seeing the first
sunrise.
Yeah.
Well, the highlight of that was the service propulsion engine burn. The lunar sunrise was impressive, but then to have the service propulsion engine kick on and steal away our life-saving velocity, that caught my attention a lot. And the burn was perfect. We knew we were in the right orbit, but we knew we would be there forever if indeed that engine didn't work again. So that was a sobering thought. And that sort of detracted from the first view of the back of the moon. The impression about the back of the moon was, for the first time, that it was a lot rougher than the front of the moon, the side that's always exposed to the Earth. And I think geologists are still debating why that is.
Did you have any assignments that, as you went around the backside of the moon, things that you were supposed to be scientifically paying attention to?
Well, I was the designated photographer as well as the flight engineer on the flight, so I had to divide my time by making sure the spacecraft was working and going through a very full photo schedule. And so that had me very busy back there, changing fill, changing f-stops, setting up cameras, and et cetera.
What kind of a platform is the Apollo spacecraft for a photographic platform?
The Apollo was the best platform that happened to be behind the moon at that time, by far. But it wasn't a great photographic platform. The cameras did shoot out the windows. They were obscured a little bit by the haze on the film. Jim Lovell was running a camera through the navigation, looking at the moon through a soda straw. It wasn't a great platform, but this was the first time humankind had been behind the moon. So it came back with some pretty spectacular photos.
Well, I've asked Borman and Lovell this question. I'll ask you too. There's a famous photograph, the earthrise photograph.
Mm-hmm.
Now, who took that photograph?
Well, that has been researched, and I think almost everybody now will admit that I happened to take the photograph that was replicated on the stamp. Frank, we found out recently, took the first earthrise, but it was in black and white. And I happened to take the first earthrise in color, and that's the one that has been of significance. So I guess we can both share the glory. Lovell has jokingly said that in order to break the tie, he was going to claim he took the first picture.
What did you think when you saw that earthrise? I know you took a photograph of it, but it must have been beyond the test pilot attitude or the pilot attitude, emotionally, human. What went through your mind?
To see the Earth come up over this very stark, battered, almost boring lunar horizon. And we'd been in Earth orbit for 3 orbits, and for some reason had not seen the Earth. We were going backwards, we were upside down. We'd been trained to look at the moon. We hadn't been trained to look back at the Earth, even though as we had gone to the moon, we could see the Earth, and it was amazingly beautiful. But to see it contrasted by this stark lunar horizon, the only color that we could see in the whole universe, in my mind, was very impressive, very actually emotional. And immediately I thought, well, how ironic, lower the moon. And yet, to me, the most interesting thing, the most significant thing was looking back at our own planet, the Earth.
Good, let me stop you.
We'd spent all our time on Earth training about how to study the moon, how to go to the moon. It was very lunar-oriented. And yet when I looked up and saw the Earth coming up on this very stark, beat-up lunar horizon, an Earth that was the only color that we could see, a very fragile-looking Earth, a very delicate-looking Earth, I was immediately almost overcome with the thought, here we came all this way to the moon, and yet the most significant thing we're seeing is our own home planet, the Earth.
Did you start taking pictures of the Earth?
Well, we took pictures of the Earth, and of course, those pictures have actually stood out in the history of Apollo as some of the most significant things. The pictures of the Earth from the moon on Apollo 8, the first pictures of our own home planet, and the lunar landing itself on Apollo 11, in my view, were the 2 most significant things of Apollo.
Frank, every time I'd ask a science question, Frank would say, ask Anders. What was the attitude about science? Frank's attitude about science versus your attitude about science for this Apollo 8 mission?
Well, Frank is a very highly technically trained guy, but he's more from the flight test background, and I had been trained as a nuclear engineer as well as a fighter pilot, and so I had probably a little more open attitude about doing science on the flight, and yet Frank, I can't fault his discipline whatsoever. This was the first flight to the moon, and if this turned into a flying science lab, and because somebody dropped a test tube, we didn't make it back, all the science in the world would be for naught. So the real mission was to get to the moon, go around the moon, and come home safely. And as long as science didn't intrude on that mission, as long as it could be about a third level importance job, then Frank would tolerate it. And I think his discipline gave us a pretty good balance. The photographic regime was a little too intense in retrospect, and Frank realized that in real terms. I was caught up in it. He aborted it. And in retrospect, I was disappointed at the time. And actually, when he ordered me to go to sleep, I laid under the couch and peeked out the window. Didn't sleep at all. But we made it back safely. We might not have, and so I don't fault and I congratulate Frank and others before him who had said, look, we can't be overwhelmed by the scientist. And they got a lot of science out of later flights. Apollo 8 was not a scientific mission.
Talk to me about being ordered to sleep. That's an interesting story point. How did that come about?
I don't remember the exact sequences, and yet it was clear I'd gone almost the whole flight without having slept. Both Borman and Lovell snored, or if when they went, and also they were together on watch, and I was alone, awake, and so when I was trying to sleep, they were awake, and they'd chat about football scores and the spacecraft, and Frank was a little deaf, so Lovell had to talk loud, so I didn't sleep very well. Plus the fact I was concerned about the spacecraft, and it was my job to keep it running. And it was not a very great place to sleep. I always felt like I was, just as I'd drop off, I'd feel like I was falling out of bed like you do. And so I'd gone about, I guess, 3 days with no sleep. Though zero G is not a very trying environment, you know, you're floating around. I think Frank either detected or realized in theory that people who hadn't slept very much are more prone to make mistakes. So he decided that with the burn to get out of orbit, to add the velocity back by reigniting the rocket was so critical. And I was the flight engineer and the one to make sure all the valves came on and the signals, blah, 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 worked at a time, but he would rather have me less photographs, more sleep than I would have personally selected. And so we got into a little debate about it, but he was the boss, and so I saluted smartly and at least looked like I was sleeping.
How did Jack Schmitt help you in training for Apollo 8? What did he try to help you with?
Well, Jack Schmitt was a real geologist and a good teacher, and so I wanted to, on the thought that maybe we would never go back to the moon. Who knew? You know, if this flight wasn't successful and all we do is whistle around it once and barely managed to make it, that maybe the United States, who didn't want to be embarrassed in space, they wanted to put the moon in, but they didn't want to crash, might not go. So I wanted to make sure that my one chance of seeing the back of the moon, I could bring back as much geological lunar science as I could. So Jack would come down and we would sit in the sauna and go over, you know, basic geology, impact craters versus volcanoes, and I had a personal interest in this anyway. So he was very helpful in that, as were others, and I came up with a kind of my own little checklist on how to identify rocks, so he was a very helpful guy in that regard, and that's why I had no inhibition about recommending that he fly later to, or at least some geologists, and he was the only geologist we had in the program, that some geologists ought to fly on Apollo before it was terminated. So
Do you think that the Apollo 8 photos, did they serve a purpose? Did they, later on, upon looking at them, did they contribute to the scientific record? Are you proud of that?
The Apollo 8 lunar surface program photos probably contributed some science, though their accuracy and ability were exceeded in later flights when they had better camera equipment, better windows. Had they been the only photos, they would be a treasure trove for science, but they weren't. There were quite a few more Apollo flights, not to mention the up close looking at the rocks right in the eyeball. The photo that I think contributed the most, not so much to science but to politics, was the Apollo 8 earthrise photo that was replicated on the stamp that everybody swooned over. I think it gave a jump start to the environmental movement. It helped point out that not only is the Earth delicate and fragile, but it's also very finite. It showed the political leaders that there really was only about that much difference between Washington and Moscow. And so I think this has had a subliminal aspect of not just the Apollo 8 flights, but all of the views of the Earth from the moon have let the human race and its political leaders and its environmental leaders and its citizenry realize that we're all jammed together on one really kind of dinky little planet, and we better treat it and ourselves better, or we're not going to be here very long.
You described the moon as a forbidding hole in the stars. What gave you that impression?
Well, this is
Play that back to me.
As we were starting to prepare ourselves to go into lunar orbit, and after we had lost contact with the Earth, we suddenly went into the double umbra of the moon. That is the shadow from the sun and the shadow of Earth shine. So it suddenly became extremely dark. There was no reflected light. There were untold stars. The navigational stars were washed out because now all these higher magnitude stars could be seen. We went from hardly being able to see stars at all to swamp with stars. And so here, looking out the window, was this magnificent star show. And as I turned around and looked over my shoulder, sort of in the direction we're going, suddenly the stars, there was a line, a curved line of no stars, of an immense black hole. And and the hair sort of stood up on my neck, and I realized that that was the moon. That was the dark hole of the moon. And I had a kind of a feeling of falling into a dark hole, and it was a little eerie, but then I realized, well, we were in lunar orbit, and that, I put in my scientist, not my emotionalist hat on, and was able to overcome the hair, get him back down on my neck.
That's a good story. You had some concern over the hatch. That was a leftover concern from the fire. Can you talk to me about that a little bit?
Well, in the Apollo fire, one of the reasons attributed to the crew's death and therefore lack of rescue was that the hatch had to was designed to open inward, and they couldn't release it in a hurry. And so part of the quote-unquote fix was to have an opening hatch. I think that was a mistake. We didn't have any other fires. A hatch that opened outward in a pressure vessel pressured 5 psi over vacuum was, in my view, an accident waiting to happen. And I would have rather had the old hatch, because I kept looking up at this mechanical engineer's dream of levers and hooks and latches, thinking, boy, if one of those fails, this hatch is going to pop off, and we're going to be, popped into vacuum of space. So that worried me a little bit. As an engineer, I thought that was the one fix on Apollo that was sort of politically correct. It was designed for a launch pad problem, and and here we were going to the moon, and we shouldn't have. That's one fix I think we shouldn't have made.
Do you think your wife was as concerned as Susan Borman was about the prospects of how well this was going to turn out? Oh, out of film. One more roll. We're all set. Take one.
Well, I can't speak for Susan Borman's concern. If Susan Borman was concerned or massively concerned, she hit it well. Good, dutiful wife. I have read subsequently that she was quite concerned. And I really can't speak for my own wife's concern. She was very supportive. We had talked this over. We'd talked about the hazards. She had 5 children, no insurance, so every right to be concerned. But the wives, of course, had been married to fighter and test pilots. They hadn't left them, and they weren't stupid, so they had digested these problems. And in my view, Apollo 8 was really maybe even less dangerous than the earlier planned mission. We didn't have a lunar module to test, so from a hardware point of view, even though we were the first ones on the Saturn V, we could have been anyway, but going into Earth orbit, we weren't exposed to any lunar module hazards. We had the additional hazard of suddenly being heaved out to the moon, but NASA had been thinking about that for a long time. So personally, and you can die in lunar orbit just as easily you can die. I mean, you can die in Earth orbit just as easily you can die in lunar orbit, as the Russians have shown. So I didn't take this flight to be any more dangerous, and I probably communicated that to my wife. I don't know whether she was more concerned than Susan or not. She was concerned, but she wasn't, breaking down over it.
Airline towelettes, what does that smell remind you of?
It makes me sick to smell them because it reminds me of trying to clean up the spacecraft, after our leader had a few problems.
Oh yeah, what happened? What happened with Frank?
Well, didn't you ask Frank? I mean, didn't he?
Yeah, Frank has told me the story before.
Well, for whatever reason, Frank became ill, quite ill. Initially just vomiting and then worse. And as easy as 0G makes life, it also has some very bad attributes. In other words, all the things human functions have to do on Earth, many of them are greatly aided by gravity. Things go down into the toilet, into the vomit bag. In 0G, they just go. And whichever way they start, they keep going until they hit something. And so when Frank became ill, the smell was pretty close. The smell was pretty bad. So I immediately grabbed an oxygen mask that was supposed to be there for a pad fire. And I figured we're not on the pad anymore, so I'm using this oxygen. And then Jim Lovell and I had to kind of net this stuff out of the air like chasing butterflies with paper towels, and then we had to clean up with these little airline type deals, take a bath, and that's not a good way. And so every time I smell one of those airline little rip open towels, I'm immediately flashback in my brain to this other stuff.
You told Mike Collins at the return home. Was it pretty uneventful? You mentioned it was Isaac Newton was driving. What does that mean?
Well, once we made the maneuver behind the moon, it turned out to be so precise that we didn't need any correction all the way back from the moon. And we had to come 240,000 miles to hit something that was a re-entry target about the size of a letter slot seen from about 4 miles away. We had to slide the letter into that slot. And the initial throw was good enough that letter went right through the middle of it. And so there weren't any corrections to be made. The spacecraft just had to be maintained. We fell for 240,000 miles, really. Frankly, it was kind of boring. Seeing the Earth from the spacecraft was exciting, but after you've seen it for 7 days, that tends to wear thin as well. And so one time when I was on watch, Mike Collins called up and asked me how things were going, and I must have said something like, well, it was a little bit boring, probably amazed everybody on the Earth. And he said, well, who's flying the spacecraft? Well, I was at the controls, but I commented that really Isaac Newton was flying the spacecraft and Isaac was in control, and we didn't have much to say about it.
You were scheduled for Apollo 13. You were originally scheduled for 13. Why didn't you make that flight? And do you think it would have been different if you had? A rookie had.
Well, I had been assigned to Apollo 13 as the normal revolution of the backup crews before the crews had been announced. And then I was asked by the president to come to Washington to help formulate the post-Apollo program, which I had been complaining about as don't expect the American people to support lunar landings ad nauseum. They really were to jam the flag on the moon once or twice maybe, but not 20 times. And so I went to Washington, and Ken Mattingly, my backup for that flight, was assigned to my place. Very good guy. Ken was a bachelor, though, and had never had been exposed to all these childhood diseases, and even as a child, he'd never, as far as he knew, had the measles. So when one of the other backup crew, Charlie Duke, came to the simulator and then later found out that one of his children had the measles, NASA very shortly before the flight, NASA was justifiably concerned. They didn't want Mattingly coming down with the measles in lunar orbit, particularly when he's going to be the only guy in the command module waiting for Lovell and Lovell and Hayes to come up for the rendezvous. So they picked a guy who'd been the third or fourth level backup, and Jack Schweigert, who was a good guy but just hadn't been trained. And so they went into a massive training program, mainly to train Jack how to rendezvous. And so that was the focus, and they decided sort of at the last minute that, okay, he was trained well enough, and they take the chance to send him out on the rendezvous. Of course, unbeknown to any of us, a thermostatic switch inside Apollo 13 had welded shut during a test. It was a switch designed for AC current, which is much less demanding than DC current, and this was a DC circuit. And so during the testing, somewhere along the line, this switch welded closed. So the thermostat didn't work, just like the thermostat in your house on your heater. If you turned your heater on, it would just keep heating and heating and heating until you realized you were too hot. It's my view that probably Apollo 8 had the same thermostatic switch welded shut, and we didn't know it either, and probably Apollo 11. But at least in our flight, I didn't want to trust the thermostats. And so whenever we needed to heat up the cryogenic oxygen, I would turn on the heater switch, watch the pressure, and when the pressure got up to where it should, well before the thermostat would cut it off, I would turn the heater off. And so on our flight, obviously we didn't have any problem. On their flight, for whatever reason, and we can't ask Jack Schweigert because he's not with us anymore, they left the heater switch on. And when it got up to the thermostatic control level, which was still safe, it didn't cut off because the switch was welded closed. And then it just kept heating and heating, and for some reason they didn't observe the pressure, and it eventually popped the tank. And when one tank popped, it took out the other tanks, so they were without cryogenic oxygen.
What would have happened to you guys if the same thing had happened to 13 that had happened at 8? What would have been the ramifications?
Well, I had thought about that, about the loss of the cryogenic oxygen, and I think that we probably could have made it. We could have used, and to the degree Apollo 13 was using, the lithium hydroxide canisters in front of our mouths like gas masks to absorb the carbon dioxide. We didn't need to have the fans. In fact, that whole sequence about the canisters and the lunar module and duct taping, in my view, was a little bit of Hollywood cranked in there, because they could have put them right in front of their mouths, and in zero-G, that's no great challenge. In fact, I think they suggest to the crew that they duct taped them to their heads, and that in their irritation they decided they weren't going to stand for that, so they duct taped it to the lunar module.
But you didn't have a lifeboat, though. You didn't have a lamp.
We didn't have a lunar module whose only lifeboat function was to provide oxygen, really. I mean, they think they did make a corrective maneuver. In our case, we didn't have to make maneuvers. Maybe we would have. And that if it happened right after our insertion to a lunar trajectory into going to the moon, and we had therefore 4 days to go out and back around on this free return, that if anything, we would die of lack of pressure. We would breathe the oxygen down. But we did have we had reentry oxygen, we had emergency canisters, and so if it happened later in the flight, we probably, I'd give it as a 50-50 chance.
Finally, do you have any regrets about?
But I wouldn't have been, it would have been a better book because we didn't have a lunar module.